Okay, this is 2010, question number 3 on the free response question. So I went ahead and did a part because there's a lot of writing and I didn't want to take up that much video time. So basically, you have this function which is only defined by graph. We don't have any equation for it, so we only have a graph. And this function, some things we should note about it, and I'll try to do this, sometimes it works. There are 700 people to begin with, so anytime you're given information in a free response question, you want to circle it or note it in some way. So as you're reading the problem, you remember to go back and add that information. You need it somewhere. So we start out with 700 people. And then we're told that the graph is a rate. So bear in mind, we're given rates. And the rate is the rate in which people are arriving at the ride. So this is people going into the line for the ride. And then we have people moving onto the ride at a rate of 800 people per hour. So that is going to be the people leaving the line. When they get on the ride, they're leaving the line. So we have coming in as this graph and going out as a constant. So for part A, we're asked how many arrive. So to arrive, we use the rate and we integrate it. So we're looking for the integral from the beginning of the time, which is 0, to the end of the time, which is 3, of this rate. It's only defined by a graph. So we have to go back and refer to the graph. And we know that integrals of a graph is the area under the curve. So the area, I went ahead and I did it in like 4 sections. You can divide it up into however you want to divide it up, but I have 2 rectangles, 2 triangles, and I just added them together, and that's going to be the number of people that arrive between 0 and 3. So that's part A, pretty basic question. For part B, we're asked to determine if the number is increasing or decreasing. We know something is increasing when the rate is positive and decreasing when the rate is negative. So in this case, we would assume that the rate is always positive. There's always people arriving at the line. But we also have to take into account that there are people leaving the line. So what I do on this one is if people are leaving the line at a rate of 800, that's a constant rate. So if you just take something and mark on your graph that 800 mark, so going across this, sorry, not a very good straight line, we have this constant line here. This is the rate in which people are leaving. So to determine if something is increasing or decreasing, or the number of people is increasing or decreasing, we just need to know, is the rate of people arriving greater than the rate of people leaving? And in the case from 0 to 3, it is. The rate of people arriving is greater than the rate of people leaving. So we know that the number of people is increasing, because the rate is greater than the rate of people leaving. So the rate from 0 to 3 is greater than 800 as long as we're between 0 and 3. For part C, we're asked at what time is the ride the longest? When we're looking for longest, shortest, highest, smallest, we're looking for max and mins. The way that we find max and mins is look for derivatives. So the max or the min is found with the derivative equals 0. Well, the derivative in this case is people going in minus people going out. So where does this function equal 0? It equals 0 when the two amounts are equal to each other. So our options are time equals 0, time equal 3, or time equal 8. So if we're looking for when the line is the longest at time equals 0, we have 700 people. So the line has 700 people. At time equal 3, we have this number of people that have arrived, which is the 3,200, plus the 700. So that's the number of people that have come to the ride. But then we're going to subtract from that the people that have left, which is 800 people per hour, and there have been 3 hours. So we know that there are 1,500 people in the line. So at time 0, we have 700. At time 3, we have 1,500. And at time 8, which is the only other possibility, we know that the rate is way below the 800, so we know we have a lot less than 700. So this would be our final answer at t equal 3. There are 1,500 people in the line. D part, we're setting up an integral that represents the earliest time in which there's no longer a line for the ride. So again, we're looking for numbers of people, which is an integral. So we started with 700 people. We're adding that some integral starting at the beginning of time and ending at some unknown time of our function. And then in here, instead of using a t, because I'm trying to answer in terms of t, you can just sub in some other variable. We're just going to integrate this thing. And that's going to be the number of people that have arrived. This is the number of people already there. From that, I'm going to subtract the number of people leaving. It's constant. You could write this as an integral also. Or since it's constant, you could just write it as 800 times t, some unknown time. Either one of those they would accept. So there's your integral expression, either 700 plus the integral from 0 to t of the rate minus the rate of people that are getting on the road. And that's it for the question. If you have any more, let me know. Thanks for asking this one, and we'll try to do a Zoom class soon.